So we need to recognise certain features of graphs. I'm going to go through them in a second with you. But there are axes, intercepts, so we're across the x and y axes, gradients, turning points, which are maximum and minimum points. So maximum points are points that would be that, and then minimum points would be these points. And you need to find the values of x where the functions do not exist, so that's where your domain is restricted. If there are any asymptotes, they're the main things that you're going to need to do. Now, if it's on paper 2, your calculator does most of that for you. And if it's on paper 1, it should be clear where these things are or how to identify them. So the kinds of functions you need to recognize: linear, what does that look like? Straight line. Quadratic.
Also,
That's a curve. We just briefly discussed a special word for it. What was the name?
asymptote, parabola.
Okay, so they are those or those. Cubic functions. There's pictures of them in a second, so you don't need to worry too much. Quartic. Actually, I don't know why I need to get rid of that bad boy. We don't need to worry about quartic graphs. What do you think quartic is though?
It's a forward.
Type 4, yeah. A reciprocal graph, so an exponential graph, and trig graphs. Okay, so linear. Obviously, we know all about linear graphs. They're in the form y equals mx plus c. M tells us about the gradient, and c tells us about the y-intercept. Yes, we don't need to worry anything about that really. We know everything we need to know about linear graphs. Quadratic graphs. Okay, so these are the form y equals ax squared plus bx plus c, and the highest power of x is 2. They're all parabolas and have maximum or minimum points. Okay, so it's a pretty picture there for you. Cubic graphs. So these are in the form y equals ax cubed plus bx squared plus cx plus d. Now obviously with both the quadratic and the cubic, these values of a, b, c, and or d could be 0 for some of them, okay? But they could all be written in this order. Okay, so you've got values in front of the x cubed, the x squared, the x, and then there could be a constant. Highest power of x is a 3. This is your basic cubic. So your basic cubic would look like one of these two, and that's if it was just what? Oh, shush now. Y equals x cubed or y equals negative x cubed. Okay, this one would be the x cubed. This is negative x cubed. Now, if you've got anything else fancy with it, so if you've got anything more than that, so if you've got some square terms, some x's, and some constants, then it's going to look more like one of these two. All right. This would be a cubic where the a value, this a value here, is positive, and this would be a cubic where the a value would be negative. Okay, so it's usually pretty obvious. If a is positive, you're going up first, and then down, then up, and then the negative, you're going down, up, and then down. Okay. Now your cubic could be written in factorized form, so it could be something like this. Alright, and similar principle to quadratic graphs. If this was my cubic, I would be able to tell where this graph crossed the x-axis. How would I know which values this crossed the x-axis? Tell me. If it was in this factorized form, do we use any
the x-axis? Wouldn't it have to be the...
Alright, let me go back up to here. If this was in factorized form, where would that parabola cross the x-axis? Pardon?
Minus 3 plus 7.
Plus 7 and
Minus 4.
and minus 4.
Okay.
Okay? Now I'm just going to be looking at that, thinking, why is it that? X and Y intercepts occur when, oh, actually I'll talk about it later. Oh, I'm going to keep going. So x-intercepts, where it crosses the x-axis, that's always going to be where the value of y is equal to what? 0. Good. So what I'm actually trying to do to find my x-intercepts is to solve that equation. Yeah? So if we remember solving quadratics, it's always going to be when this bracket is equal to 0 or this bracket is equal to 0. To make this bracket equal to 0, it means that x would have to be -4, and for this one it would have to be +7. So if you recall, it's always the opposite value to what's in the bracket. Yes? So that would be where it would cross the x-axis. For the cubic, it's the same principle. It's just going to cross it more times. Okay, so this one would cross at -2, +3, and -7. Yeah? Happy with that? This is obviously in our textbook to give you a bit more information. I don't think anything else. Transformations of graphs. We need to look a little bit into that, so this can come up later. Do you recall anything about moving graphs, shifting, what values do to them? We would have looked at briefly, probably GCSE. Yes?
I remember knowing it.
Just don't really remember. Okay, don't worry, we'll go through it in more detail. And the thing with graphs and functions is it's very tricky because it is a chicken and egg situation. It's like, which one do we do first? Because they all interlink so much that you need to try and teach everything. You have to try to blur everything out, and then it just gets a little bit confusing. Okay, so I apologise if it gets to that situation, but I will come back to everything, and hopefully everything will start to piece together. So yeah, if it's in factorized form, as I've said, your intercepts are going to be at the opposite values to these. Okay, so this is an alpha, beta, and gamma. Sometimes your brackets are repeated, so they would be a square bracket. That would mean that you would have a graph that would perhaps go through the axis in one place and then just touch at another. Okay, so that would be, this value here would be positive beta. Oh, let's not. So this one would be beta, and this one would be alpha, because the squared bracket is where it would just touch. It wouldn't actually go through it. Okay. Reciprocal graphs. We haven't looked at these at all, no? Okay, reciprocal graphs will look like this. They've got two branches. Okay? Your basic graph would be where this here would be a number. So for example, this could be the graph of y equals 4 over x. Now, it doesn't matter what this value on the top is, they always look the same. The only difference to them is that they might be further out. Okay? But to look at the picture, if you've got no scales on them, they all look exactly the same. They have two branches, and they do that. We can rearrange this, so we can rearrange this to be yx or xy equals 4. That means that your two values of your coordinate, your x and your y value from your coordinate, have to multiply together to give 4. Yes? So any two numbers multiplying together to give 4 would be a coordinate on this graph here. Yeah? So it would go through from 1, 4, 4, 1, 2, 2, so on. Yeah? Are we together? Are you ready? Now, these kinds of graphs have asymptotes at y equals 0 and x equals 0. This one should be obvious. Why would there be an asymptote when x is 0? Looking at the format of this graph here, why would there be an asymptote? Because you can't divide by 0. Yes, you're happy with that? Ooh. You just can't, it's impossible. Well, you can try it on your calc, it will take ever.
Dividing into like 0 groups, you're not really dividing.
Yeah. Thank you.
So that's how you count. Okay,
Okay, so you just cannot divide something by 0. So that means that x equals 0 is an asymptote. But where is the line if x equals 0? Be careful here. Where is the line? If I were to draw the line x equals 0, where is it? Yeah. Okay. Where?
For the top line.
Oh, who's somebody said something?
Creek.
Creek, y-axis, good. The y-axis is also known as the line x equals 0. Yes, do you remember that?
Yeah.
Because we know that x equals lines are always vertical, and if x is 0, it has to be this line here. Okay? So that means that my asymptote, one of my asymptotes is there. Now, to find another asymptote, what you would... For this one, it's not as easy to do this next step with you. I think it's easier just to remember that when you've just got a basic number, your two asymptotes are always going to be at x equals 0 and y equals 0. You are never going to get an answer of 0. By putting any number into here, you will never get an answer of 0. Okay? So they are your two asymptotes. Now remember, asymptotes are lines that the graph never touches. It gets really, really close to, but never touches. Okay? And they're usually shown with dotted lines, but obviously if they are the axes, you can't normally show them. Right. Now, for this format, or any other kind of reciprocal graph, it's a little bit easier to determine the y asymptote. Your x asymptote is always going to be determined by what's on the bottom of the fraction. Okay? So here, I know that if I've got x minus h, then this value here is always going to be my vertical asymptote. So this line here, this equation of this asymptote would be x equals h. Okay, so that would have to be my vertical asymptote. You would find your horizontal asymptote. The easiest way to do it is to say, okay, I need to find out what happens to this graph. I can see it's going along like this, and it's getting closer and closer to this point, but I need to know what that point is. Now, as my graph goes along in this direction, what is happening to the value of x? It's increasing, yes? It's getting bigger and bigger and bigger, right? Similar way here, I can see this one's going this way, it's getting bigger and bigger, negative, yeah? You can choose either one, it doesn't matter. The best thing to do to find horizontal asymptote is to input a value of x that's a really big number. So wherever you see an x in your equation, you would put a big number, okay? 1 million, 10 million, doesn't really matter, okay? You would stick that into your equation and you would calculate it and see what answer you get. Your calculator will always approximate. If it's got too many digits, it will approximate to something. And that will tell you the equation of the horizontal asymptote. And as I said, the reason being is because we know that this graph is getting closer and closer and closer to something. And as this happens, our x value is getting bigger and bigger. Does that all make sense? That's just explains all of that. We'll see some examples when we get to the next slide. Alright, exponential